Welcome to lesson 1-5, video 1, and this is introducing domain and range. Alright, so our learning target here is that we can identify the domain and the range of a function. The relationship between two quantities can be shown by a set of ordered pairs called a relation. And if you remember, in the very first lesson of the course, we talked about the fact that a function was a special relation in which each input x has exactly one output y, so you can fill that in your notes right there, 1. And the majority of the relations we will deal with throughout this year will be functions. But how do you know if you're dealing with a function or just a relation? So I'm going to scroll down here for y'all to fill this into your notes. Scan the domain. So scan it from left to right. So if you remember, kind of like those scanners, or if you ever go to the self-checkout, that's kind of what I think about there. You've got like a red line or a red laser in there that scans the domain of like the barcode there, and that's kind of what's going on here. Think of this vertical line. It can move anywhere left and right on this graph. And if that vertical line only intersects the graph one time, then it can be considered a function. So it has to pass the vertical line test. So right here it says if an x value repeats, you do not have a function. And if any vertical line passes through more than one point on the graph, like I said earlier, then the relation is not a function. So let's look at these visuals right here. So this first example is a function. So think if you were to take this line right here and move it left and right, this intersection here, there would only be one intersection. Even though it would move, it would only intersect that line one time. Same thing with this one. This is a function. But this last one is not, because you can see there's a point, or there's a section of the graph right here that when I draw this vertical line, it intersects in more than one spot. If I were to move this line over here and draw it, it would only intersect once. But if I move it over here, there's a point where, or there's a line rather, where when it intersects 1, 2, 3 times. So this would not be a function. Alright, so this is straight from your notes here. It says relations can be expressed in several different ways. The relation here, 2, 3, 4, 7, and 6, 8 can be displayed in the following ways. So the first way we can display it is by using a table. So I'm just going to plot these, or take these points and put them in a table. So the first point is 2. Oh, let me change the thickness. Hold on. Let me change the color. Let's do orange. Okay, the first point is 2, 3, 4, 7, and 6, 8. And I can also plot those on a graph. So we'll go right 2 and up 1, 2, 3, put a point. So that's my first point. The second point is 4, 7, so 1, 2, 3, and up 1, 2, 3, 4, 5, 6, 7. So that's my second point. And then my third point is 6, 8. So 1, 2, 3, 4, 5, 6, and then up 1, 2, 3, 4, 5, 6, 7, 8. And then the last way we can represent a relation is by using mapping. So this is similar to using the table, but I'm just going to draw my points here. So 2, or write in my points here, 2, 4, 6, and then 3, 7, 8. And I know that 2 maps to 3, and I know that 4 maps to 7, and 6 maps to 8, as we were able to get here. Alright, so the next part here says that the domain of a relation is the set of inputs, or x values, of the ordered pairs. What y values were used in this graph? How far left does it go? How far right does it go? So those are the questions we really need to ask ourselves. So which x values are we talking about in the graph. And then the range of the relation is the set of outputs or y values of the ordered pairs. So which or what y values were used in this graph? How far down does it go? How far up does it go? Okay, let's go through example 1. So what I like to do here is draw a set of brackets. My domain is going to be represented by all the numbers I list here. So the domain is all of the x values. So let's list them. I've got -1, comma, 2, comma, 0, comma, and -7. And let me change colors for the range. Let's do blue. So for the range, I've got 4, 6, 4, and 1. So 4, 6, 4, and 1. And I'll use brackets around that as well. And now the question is this a function? And yes, it is, because I have no repeating x values up here. Now notice I do have repeating y values, but that's okay. This -1 maps to 4. This 2 maps to 6, this 0 maps to 4, and that's okay. You can have y values that repeat, but you cannot have x values that repeat. All right, and then lastly, -7 maps to 1. All right, let's try this one. So the domain, we're going to have to look up here. Let me change back over to orange. For the domain, let's look at all the x values of where these dots are. So if I look at this dot here and I follow my cursor up here, it corresponds with -4 on the x-axis. This dot corresponds with -3. This dot corresponds with 0. This one corresponds with 3. And this last one corresponds with 5. And now let's do the y values. Let me go to blue again. Okay, so we're going to look at this point. We're going to see where it corresponds on the y-axis. So here at -2, and then here at 4, at 1, at -2, and lastly at 3. Now one thing to note is generally we like to write these in order from least to greatest, but for now I wrote them just in the way that they map. Okay, but generally I've also seen these written in the form of least to greatest, so just keep an eye out for that. Same thing with these over here. See, my domain is not written in order from least to greatest here, but really for the point of showing this example here and understanding what domain and range are, we're just going to leave it like this for now. Now, I do not have any repeating values of x. Okay, so this is a function. Now notice I do have repeating values of y, but again, that is okay. And also you can see that if I were to draw a vertical line through any of these values here, and I'm going to draw this vertical line here and move it so y'all can see what I mean. Right here, it only intersects this point here once. If I move it here, it's only intersecting 1 point. If I move it here, it's only intersecting 1 point. Here, it's only intersecting 1 point. And then here, it's only intersecting 1 point. So it does pass the vertical line test. All right, let's go to the next part. So here's a helpful hint, and this is one thing I wrote on the board in my classroom today that y'all were able to see. So we're adding to our list of vocab words independent variable and dependent variable. So these are all within the same category and they mean the same thing. So the independent variable will be your x values, the domain, the input, and what x is. And then the dependent variable will be the y values, the range, the output, and f of x. All right, let's do example 3. So the domain we'll list here, the domain is 2, 3, 4, and 5. So we'll list that here. So 2, 3, 4, and 5. And generally you can list the domain one time. Like you notice here I have a 3 that maps here to -3 and 5. so I'm going to add that 3 right here, even though I only need to really write it once, but it helps me see that I actually have 2 values of x, which remember is a no-no. So that means that this will actually not be a function. So let me write my range here. My range is -3, -2, 5, 7, and 9. And again, I did not write these in order from least to greatest. I'm just writing them with how they map directly. I know that the 2 maps to the -3. This 3 actually maps to the 2 maps to the -2. The 3 maps to a -3 and the 5. And that's how we know that this is not a function, because I have 2 values of x that map to 2 different things. And that doesn't really make sense, right? It doesn't make sense that you could plug in one value into a function and expect 2 different things as an output, because that one value is the independent variable, and the dependent variable is what changes based upon what the input is. So the independent variable is not going to change. Okay, let's go through example number 4. So be careful with this. It's talking about students who take AP Government. They can either earn a 1, 2, 3, 4, or 5. Last year, 2 students earned a 1. No students earned a 2. 3 students earned a 3. And 7 students earned a 4. And 7 students earned a 5. So let's list these as our ordered pairs. So last year, 2 students earned a 1. So think about what is the independent variable. So the independent variable is actually the score, because that's going to determine how many students earn that. So the independent variable here is 1. So that'll be 1. And we have a total of 2 students that scored a 1. And then no students scored a 2. So we'll say 2, 0. So the independent variable being the score, and then the number of students being the dependent variable. The 3 students scored a 3. We had 3 students score a 3, so that'll be 3, 3. 7 students scored a 4. Okay, so so that'll be 4, 7. And then lastly, 7 students scored a 5, so that'll be 5, 7. Now let's plot these. So 1, 2, 2, 0, 3, 3, 4, 7, and lastly 5, 7. So our domain is 1, 2, 3, 4, 5. And our range is, we'll write these in order from least to greatest. Our range is going to be 0, 2, 3, and 7. Now, I'm not going to write the 7 again because I don't need to, but remember, it's okay that I have 2 in the range. I have 2 of the same numbers in the range. And because I have no repeats in the domain, this is, yes, a function. And does it make sense to connect these points? No, it doesn't. These are just independent variables here, or independent. So this is discrete data, because it doesn't make sense to connect these points, because you cannot make a score in between 1 and 2, or 2 and 3, or 3 and 4, or 4 and 5. There's no values that are in between those, so it does not make sense to connect those points. So we're going to say no. Alright, so try these U-tries, and then I will see you in the next video.